Hello, today we will be doing the mathematics CBSE mathematics sample paper. Okay, section B. We have already done the section A. Now, today we will be doing sample section B. So, this is the question. Here, the section B. Question numbers 11 to 18 carry 2 marks each. There are 8 questions. Find the roots of the following quadratic equation. 11 question. Question number 11. 2 upon 5 x squared minus x minus 3 by 5 is equals to 0. So we have to find the roots. That is the value of x. So first we will have to remove the denominator. So multiplying throughout. So multiplying throughout, okay, throughout by by the LCM of the denominator, which is by 5. So now you multiply every term with 5. So here the 2, okay, upon 5 multiplied with 5 will give us 2x squared minus x multiplied with 5 minus x multiplied with 5 is minus 5x, and 3 upon 5 multiplied with 5 will give us 3. So this is the quadratic equation where the denominator has been removed. Now also 0 multiplied with 5 will give us 0. So for solving it, we will here break up the middle term, that is minus 5x. For finding out into which two terms we will break up minus 5x, we will do here a rough work. We will write m and a. So for m, we will write the product of the coefficient of x squared and the constant term. So plus 2 times minus 3 is minus 6, right, for m. And for a, we will write the coefficient of middle term, which is minus 5. So write here minus 5. Now you will try to find out two numbers whose product will give us minus 6 and the sum minus 5. So these numbers are 6 and 1, minus 6 and plus 1. Check it. Multiply minus 6 and 1. We get minus 6, which is satisfying here. Add them. Minus 6 plus 1 will give us minus 5. So both the conditions are satisfied. So now we will break up the middle term into these two terms. So 2x squared, I copy it down. Minus 5x, I will write it as minus 6x plus x. Okay, and minus 3. So it is equal to 0. Now take the common from the first two terms. It is 2x. So divide both the terms with 2x. So 2x squared divided by 2x, we get x right here inside the bracket. And minus 6x divided by 2x gives us minus 3. So right here, close the bracket. Now take the common from the next two terms. It is plus 1 common. So take plus 1 and divide both the terms with plus 1. So inside the bracket we will have x minus 3. So it is equal to 0. Now take this x minus 3 common from these both the expressions. So what is left? So from the first we get 2x, and from the second plus 1, write it within the next bracket, equal to 0. So when the product of two expressions is 0, so either the first expression x minus 3 is equal to 0, or the second expression 2x plus 1, that is equal to 0. Now from this 2x plus 1 moving other side, it is minus 1. Okay, so x value is equal to minus half. 2 moving other side, it becomes divide. Now from the here, what we are having, x is equals to minus 3 going other side, it is plus 3. So what are the values of x? Here it is minus half and plus 3. So these are the roots of the given equation. So it is the answer. Now we are moving to the next question, number 12. So what is this question saying? If the numbers x minus 2, 4x minus 1, and 5x plus 2 are in AP, find the value of x. So when the three numbers are in AP, so we have the second term minus the first term is equal to the third term minus the second term. This is called the common difference. So when the three terms are in AP, the second term minus first term is same as the third term minus the second term. So write it. So the second term is 4x minus 1. Subtract the first term, x minus 2, right, in bracket. Now that is equal to the third term, 5x plus 2 minus the second term. So that is equals to 4x minus 1, right, in the bracket. Now open both the brackets. So this is 4x minus 1. Here there is a negative sign before the second bracket. So on opening the bracket, the sign of the terms will change. So plus x changes to minus x. Minus 2 changes to plus 2. And now here we will open the brackets, both the brackets. So this is 5x plus 2. And on opening the second bracket, there is a negative sign before it. So the sign of the terms will change. So plus 4x will become minus 4x. And minus 1 will become plus 1. Now you solve this equation. First you simplify the left side and right side. 4x minus x. This gives us 3x. Minus 1 plus 2. It is plus 1. And on the right side, 5x minus 4x. It is plus x. Plus 2 plus 1. It is plus 3. Now move the x terms to the left. So 3x plus x, I am moving to the left side of the equal sign. It is minus x. And here we write 3 and plus 1, I am moving to the right. It is minus 1. So 3x minus x is 2x. Its value is 3 minus 1, which is 2. So what will be the value of x? Here 2 moving to the right, it will change to divide. So 2 divided by 2 is 1. So that is the value of x. So this sum is done. Now we are moving to the question number 3. Here it is saying two tangents PA and PB are drawn from an external point P to a circle with the center O. Prove that AOBP is the cyclic quadrilateral. Now we are doing this sum. Okay, first you draw the figure. Here the figure is not given in the question. So you draw a one circle, okay, and mark its center as O. Now there are two tangents drawn to the circle from an external point P. So from P we are drawing two tangents. So this is PA is the first tangent. And from the P we draw another tangent. So this is PB. Okay. Now you join A to O and B to O. Now here we have to show that this quadrilateral PAOB is a cyclic quadrilateral. So in a cyclic quadrilateral, the sum of the opposite angles are together 180 degree. That means we will show the angle PAO plus angle PBO together is 180 degree, and angle APB plus angle AOB together is 180 degree. So this quadrilateral will then be the cyclic quadrilateral. So how we will do this sum? First you write given. Okay, this is the method of writing the geometrical proofs. First you always write given. So here it is given a circle. A circle with center O. Okay, right here. Now from the point P, from the point P, okay, two tangents, two tangents, PA, PA and PB and PB are drawn to the circle, are drawn to the circle. Now, here, required to prove. Next, you have to write required to prove, RTP in short. Here, what we have to prove that AOBP is a cyclic quadrilateral. That means all the corner points AOBP are lying on one circle. So it is a cyclic quadrilateral. We have to show it. Okay. So how we will show it? Now see here. I am writing the proof. So now you please pay attention. Here, angle PAO is 90 degree because the radius perpendicular to the tangent. So PAO is equal to 90 degree. Why? Because the radius is perpendicular to tangent. Okay, write this as statement number one. So similarly, here angle PBO is also 90 degree. Angle PBO is also 90 degree. It is same reason. Okay, if the reason is repeated, you write same reason. No need of writing again the same thing. Okay, this is allowed in geometrical proofs. Okay, now here therefore what we get? So therefore angle PAO plus angle PBO together is 90 plus 90 degree. 90 degree plus 90 degree, which is equals to 180 degree. So now, so in any quadrilateral we know that the sum of the four angles together is 360 degree. So the other two angles, that is angle APB plus the angle AOB together will be how much? How many degrees? It will be 360 degree minus the angle PAO, okay, plus angle PBO. Write the reason, because every step you have to write the reason. Without reasoning, it will not be accepted. Marks will be deducted. So it is because sum of the angles of any quadrilateral, of a quadrilateral, of a quadrilateral together is equal to 360 degree. So that is the reason why the sum of these two angles is, okay, this 360 minus the sum of these two angles. So angle APB plus angle AOB is equal to 360 minus PAO plus PBO, which is already we have showed it is 180. So it is minus 180. So 360 minus 180 is 180. So we have showed that the sum of the opposite angles of this quadrilateral together is 180 degree. So it is proved that the given this quadrilateral, so therefore AOBP is a cyclic quadrilateral. That means all the four corner points are lying on one circle is a cyclic quadrilateral. Okay, so it is proved. So this was asked to prove. We have proved it. Okay, now we will be going to the next question. So this is proved. Okay, now we are moving to the question number 14. Now, what is this sum saying? In the figure, there is a one figure given, figure 2, it is marked figure 2. A circle of radius 7 centimeter is inscribed in a square. Find the area of the shaded region. So this is the given figure. Mark the corner points like A, B, C, and D, and draw here, and it is touching the circles at the point E, F, G, and H. Okay, now join H and F. So here this length HF will be the diameter of this circle. So the diameter is twice the radius. So that will be 14 centimeter. So which is equal to the length of the sides of the square. So because AB and DC will be same as HF, and AD and BC will be same as the length of GE, which is also 14. So here the diameter, radius is given. Radius of circle which is inscribed inside the square uh, is given to us. We are denoting it by the letter R, which is 7 centimeter. So the diameter, diameter of the circle is equal to HF, or it is same as GE, which is equal to twice the radius 2R. So it is 2 times 7, which is equal to 14 centimeter. So the length of the sides of the square is same as the diameter. So the length of side of the square. So the length of the sides of square is equal to the diameter, which is HF, or it is also equal to GE, which is equal to 14 centimeter. So what is the area of the square? So area of square ABCD. ABCD. We know the formula of the area of the square is side times side. Here the side is 14. So 14 times 14 centimeter squared, which is equals to 196 centimeter squared. Okay, now we will find out the area of the circle. So area of circle, what is the formula? We know its formula is pi r squared. Put the value. Pi value is 22 by 7 times r squared. R is 7. So 7 times 7, it is so many centimeters squared. Cut 7 from the top and down. Now multiply 22 times 7. So 7 times 2 is 14, carry 1. 14 plus 1 is 15. So it is 154 centimeters squared. So what is the area of the shaded region? So therefore, area of shaded region is equal to area of the square, is equal to area of square, okay, minus the area of the circle. Now you subtract here. So area of the square is 196 minus the area of the circle, it is 154. So subtract it. That is the area of the shaded region. 6 minus 4 is 2, and 9 minus 5 is 4. So it is equal to 42 centimeters squared. So that is the area of the shaded region. Now we will be going to the next question, number 15. Here it is asking how many spherical lead shots each having the diameter 3 centimeter, can be made from a cuboidal lead solid of dimensions 9 centimeter times 11 centimeter times 12 centimeter. So, how we will do it? The sum. You pay attention. So, here it is given to us diameter of of spherical diameter of spherical lead shots. Okay, now here I am denoting diameter by the letter D. It is given to us 3 centimeter. So what is the radius of the spherical lead shot? So therefore, radius of spherical, okay, spherical means the shape of the football. Spherical lead shots. So it is equal to, we are denoting by the letter R. So this is D divided by 2. So it is 3 upon 2. So many centimeters. So the volume of one spherical lead shot. So what is the volume of one spherical lead shot? So formula of the sphere is 4 by 3 pi r cube. Now put the values. So it is 4 upon 3 times pi. Pi value is 22 divided by 7 times r cube, which is 3 upon 2 times 3 upon 2 times 3 upon 2. So many centimeter cube. Now divide 4 with 2. So here we get 2. And divide this 2 with 2. Here you get 1. Again you divide 2 from the top. You get here 1. And cut this 2. You get here 1. 22 you divide with 2. Here you get 11. And 2 you divide with 2. You get here 1. Now 3 you divide with 3. You get here 1. And cut this 3. You get here 1. So now multiply 11 and 3 times 3 is 9 divided by 7. It is so many centimeter cube. Now the volume of okay cuboidal okay lead solid. So lead solid. So what is the formula? It is length times breadth times height. So it is equal to 9 times 11 times 12. So it is 9 times 11 times 12. So many centimeter cube. So the number of spherical, therefore number of spherical, okay, spherical lead shots made. So lead shots made. That is the question. Its formula will be, you divide the volume of okay cuboid, volume of the cuboidal lead solid, okay, by the volume of one spherical lead, okay, one spherical lead shot. So volume of one. So volume of one spherical lead shot. Okay, you will get the number of lead shots made. Now you write the volume of the cuboidal lead solid on the top. So what is the volume? It is 9 times 11 times 12. So many centimeter cube. Divide this by the volume of one spherical lead shot. It is 11 times 9 divided by 7. So many centimeter cube. Cut centimeter cube from the top and down. So this is 9 times 11 times 12, and this 7, which is the denominator of the denominator, that 7 will move on the top. Okay, and 11 times 9 will be written at the bottom. So cut 9 from the top and down, and 11 also from top and down. So 12 times 7 is 84. So 84 spherical lead shots are made. So that is the answer of question number 15. Now we are moving to the question number 16. Now what is this sum saying? Here it is saying point P, coordinate is 5 comma minus 3, is one of the 2 points of trisection of the line segment joining the points A 7 comma minus 2 and B 1 comma minus 5. Okay, near to A, find the coordinates of the other point of trisection. So trisection means the points which divide a line segment into three equal parts. So first you draw the straight line. Okay, you write the endpoints of this straight line segment as A and B. So A coordinates is here 7 comma minus 2, and the coordinate of B is 1 comma minus 5 right here. Now mark here 2 points, one point here and another here, okay, in between A and B. So the point which is closer to A, it is named P because it is told to us in the question. P is near to the point A. It is told to us. It is near to A. And the point P coordinates are given. It is 5 comma minus 3. Okay, the coordinate of other point of trisection is to be found out. Let us call the coordinate of Q. This point, the next point, which is trisecting AB, we are calling this point by the letter Q. Let its coordinates be x and y. So we have to find the values of x and y. Now the trisection means that these points P and Q are dividing the line segment into three equal parts. So it means AP length is equal to PQ is equal to QB. All these three parts are equal in length. So AP, PQ and QB are all equal. So this point Q divides the join of A and B in the ratio 2 is to 1. This part is, okay, 2 times bigger than QB. So AQ is to QB is 2 is to 1. Okay, so AQ is to QB is here 2 is to 1. So this is the ratio in which Q is dividing the join of A and B. Okay, this 2 we are denoting by the letter M, small m, and 1 by the letter N. Okay, now how we will find the coordinate of Q? So here the coordinate of Q are found like this. Formula is M, okay, multiply with the coordinate of the par coordinate of par x coordinate, that means the coordinate of B. So it is mx2 plus nx1, multiply n with the par x coordinate, that is the x coordinate of A, okay, nx1 whole divided by m plus n, okay, and comma the y coordinate is similarly my2. So m is this aq, okay, 2 is to 1. So m is 2. So 2 multiplied with the par y coordinate, that means the coordinate of y coordinate of B, plus n multiplied with the par, okay, y coordinate, that is the coordinate of A. So it is ny2, okay, sorry, ny1, okay. Now whole divided by m plus n. Now you put the values. So here it is Q is equal to m. M value is 2. So 2 times x2. X2 is the x coordinate of B, which is 1, plus n. N value is 1. Multiply with x coordinate of A, which is 7, whole divided by m plus n, which is 2 plus 1, comma. Now my2 is 2 multiplied with the power y coordinate, that is the coordinate of b, y coordinate of b. So 2 times y coordinate of b, I am putting minus 5 in bracket, plus n value is 1. Multiply 1 with the power y coordinate, that is the y coordinate of b, a, sorry. It is 1 times minus 2, whole divided by m plus n. So which is 2 plus 1. So now you simplify it. So 2 times 1 is 2, plus 1 times 7 is 7, whole divided by 2 plus 1, which is 3. And here, comma, 2 times minus 5 is minus 10, plus 1 times minus 2 is minus 2, whole divided by 2 plus 1, which is 3. Now you simplify it. So it is, we are getting q is equals to 2 plus 7 is 9. 9 upon 3, comma, minus 10 minus 2 is minus 12 upon 3. So now this gives us 9 divided by 3 is 3, comma, minus 12 divided by 3 is minus 4. So this is the coordinates of q. So it is the answer. Now we will go to the question number 17. Show that the point minus 4, 2 lies on the line segment joining the points minus 4, 6 and b minus 4, minus 6. So, how we will show this point P is lying on the line which is joining A and B. So, first you find the equation of the line AB. Okay, now see the formula for the equation of a line passing through 2 points. So, this line is, suppose I draw the line like this. Here the point I am marking. A, it is minus 4 and 6. B is here minus 4 minus 6. Okay, the one coordinate you call x1 y1, any one. Either you call the coordinates of A x1 y1 or the coordinates of B as x1 y1, and another coordinate you call it x2 y2. Now the equation of line AB is, formula is here y y minus y1 divided by y2 minus y1 is equal to x minus x1 divided by x2 minus x1. Now you put the values. So equation of line AB is what? Here y minus y1. y1 is the y coordinate of A, which is here 6. So right here 6 divided by y2. y2 is the y coordinate of B, which is minus 6. Right here minus 6 minus y1. y1 is the y coordinate of A, which is minus 6, is equal to x minus x1. x1 is the x coordinate of A. It is minus 4, right? Minus 4 within the bracket, divided by x2. x2 is minus 4. Right here minus 4 minus x1. x1 is the x coordinate of A, which is minus 4. Now you write minus 4 in bracket. Now you simplify this. So this is y minus 6 divided by minus 6 minus 6, which is minus 12, is equal to x, open the bracket. So negative sign is before the bracket. Minus 4 within the bracket will become plus 4. And here also minus 4. Okay, on opening the bracket, it will become plus 4. So now you simplify. So this become y minus 6 divided by minus 12. And here it is x plus 4 divided by minus 4 plus 4 gives us 0. Now you do the cross multiply. So this becomes 0 times y minus 6 is equals to minus 12 times x plus 4. So now 0 multiplied with any number is 0. This gives us minus 12 times x plus 4. So this can be written like this. Okay, so we can write it like this. Minus 12, you write on the left this. Minus 12 times x plus 4 is equals to 0. So what will be the value of x plus 4? Dividing both the sides, now minus 12 I am taking to the right side. So 0 divided by minus 12, it is 0. So the equation of line AB is here what we are getting x plus 4 is equal to 0. Let us call this equation. Now for checking that whether the p point minus 42 is lying on the equation on the line AB, you put that coordinates of p in the equation number 1, which is the equation of the line AB, and you check whether that coordinates satisfy the equation or not. If it satisfies, it lies on the line. Otherwise, it does not lie on the line. Therefore, putting these coordinates, putting P, okay, what is the coordinate of P? Minus 4, 2. So putting P minus 4 and 2 in equation number 1, which is the equation of the line AB. So left hand side is, in place of x you put the x coordinate of p, which is minus 4 plus 4. So minus 4 plus 4 gives us 0, which is equals to right hand side. So this coordinate of p satisfy the equation number 1, which is the equation of the line AB. So therefore it is proved p point minus 4 2 lie on the line on the line on the line AB. So this was asked to prove. We have proved it. Now we are going to the last question of this section, B. Okay. Now here there are two questions. Okay, choices. Either you do the above question or lower question. Either any one, not both. So, but we will do here both of these questions. So, I am calling the question number on the top by A and the question which is written in the lower part by B. We will do both here. Okay, now first I am doing the above question. That is question on the top. Okay, that is A. So, two dice are thrown at the same time. Find the probability of getting different numbers on both the dice. So let S be the total sample space. Let S be the total sample space. That means total sample space means the all possible outcomes in the throw of two dice. Okay, so let S be the total sample space in the throw of two dice. Of two dice. Now, what is the total number of all possible outcomes? We know that in a single throw of a dice, there are six possible outcomes, any one number out of six. Similarly, in the second dice, the possible number of outcomes are 6. So the total number of possible outcomes in the two throw in a single throw of two dice is 6 times 6, which is 36. So ns, so ns, okay, is equal to, this is called ns. So which is equal to the total possible number of outcomes. So ns is 36. So all possible number of outcomes is 36. Now in the question, we have to find the probability of getting different numbers on both the dice. So let us first find what is the probability of getting same number on both the dice. So let us call that event. Let the event, let the event of getting same number, let the event of getting the same number on both dice, on both dice, is denoted by the letter E. So here E will be what? So same number on both the dice. So one on the first, one on the second, two on the first, two on the second, three on the first, three on the second, four on the first, four on the second, and five on the first, five on the second, six on the first, and six on the second. So what is the NE? So the number of outcomes possible to the event E, that is here count. Okay, that is number of outcome favorable to the event. Here it is 1, 2, 3, 4, 5, 6. So NE is equals to 6. So the probability of getting the same number on both the dice, it is denoted by PE. That is the probability of getting same number on both the dice. It is NE divided by NS. That is the number of outcomes favorable to the event divided by all possible outcomes. So NE is 6 divided by NS, which is 36. So you divide both the numbers on the top and down with 6. 6 is the common factor, it is 1 by 6. So the probability of getting, therefore, probability. So the probability of getting different numbers, different numbers, okay, different numbers on both the dice, on both the dice. It is, we call it E complement or not E. It is denoted by PE dash. That is not E. Okay. Okay. It is, a formula is 1 minus PE. Okay. So it is equal to 1 minus PE. So what is PE? It is 1 upon 6. So now you subtract it. Take the LCM 6. So 6 minus 1, which is 5 upon 6. So that is the probability of getting different numbers on both the dice. Now the B part, the lower question. So above question we have done. Now the lower question we are doing, that is B. We have to do any one, but we are doing both. Here the number B question is this. A coin is tossed 2 times. Find the probability of getting at most one head. At most one head means either one, at most one head. That means either no head or one. That means not two. Okay. So here a coin is tossed 2 times. That is the same coin is tossed 2 times. So let S be the total sample space. Let S be the total sample space. Sample space means all possible outcomes. Let S be the total sample space in the throw, in the throw of a, a coin 2 times. 2 times. Okay. The same coin is thrown 2 times. So here S will be what? Here S will be that first coin head and the second coin is also head. Head we are denoting by the capital letter H. And the second, okay, possibility is this. First head and the second tail. Or the third possibility is this. First tail and the second head. And the fourth possibility is tail on both the coins. So these are the four possible outcomes. So NS, what are the number of all possible outcomes? It is 4. Okay. Now here, okay, we have to find what is the probability of getting at most one head. So let us call that event by E. So let the event of getting, so let the event of getting at most, okay, one head. We are denoting that event by the letter capital E. Now E will be what? At most one head. That is either one head or no head. So it is head T, HT. That is first coin head, second coin tail, or first coin tail, second coin head, or tail on both the coins. So these this these are the possible outcomes of at most one head. So what is the number of okay outcomes favorable to the event? It is denoted by NE, which is 3. So what is the probability of the event E? PE. That is at most one head. What is the probability of getting at most one head? It is denoted by PE. It is equal to NE upon NS. That is the number of outcomes favorable to the event E divided by all possible outcomes. So which is 3 divided by 4. So this is the probability of getting at most one head. So this section B is completed. Now one more section is left. C we will be doing in the next class. I hope that you must have understood all the questions how to do it. Okay, so have a very good day. We are end the class now. Okay, so bye. Thank you.